Per what you have learned so far, if you look at my previous video, I gave you the formula for finding a probability for a particular event. Now let's look at that formula. You said that probability for a particular event, let's say event A, is equal to the number of obtaining event A over the number of what? Sample space. In the case of the examples that we did, you realize that always the sample space is given, the event A is given, and you have to find the probability of the event. What if event A is not given, but rather the probability of the event, the number of the sample space is given? What do we do? Or what if the sample space is not given, but rather the number of events and the probability is given? What do we do? Let's look at that one too. So, in this case, I need number of what? Events. If the probability of the event and the sample space is given. So here is over 1. If I do cross multiplication, I'm going to have 1 times this is number of what? The events equals this time that is going to give us probability of A times number of what? Sample space. So this is how it's going to be, or it's going to look like. So this is when the event is not what? Given. That's the formula you are going to use. And in a case where so let me write this one. The event is not given. Okay, that's when we use this formula. Now, from this formula, let's say when the sample space is not given, this is what we are going to get. You divide both sides by probability of A here. So this will cancel this. Means that if the sample space is not given, the formula is going to be number of what? Events over the probability of the events. So this is the sample space is not known. So when the sample space is not known, this is what you are going to use. And when the event is not known, this is the formula you are going to use. So take note of these two formulas. Thank you. Now let's look at an example of such natures. So now let's look at the first example under this. Let me read the question. There are 20 bees in a bag. The probability that a red bee is taken at random from the bag is 1/4. So in this case, let me put data down. Probability of obtaining red bee is given as 1/4. Find the number of red bees in the bag. The number of sample space has been given as 20. The number of sample space is 20. Now you want the number of the event of obtaining what? Red bees. So this is the information. And he said that if you want that, the formula is given as probability of obtaining that times number of what? Sample space. So since we have them already, this is 1/4 times 20. 4 goes here, 1 goes there, 5. So we have 5 red bees. Simple, right? Okay, now let's look at second example. Let's look at example number 2. A box contains 25 balls. So I'll be taking the data whilst reading. So Our sample space is 25. Some of which are blue and others are green. If the probability of picking a green ball randomly from the box is 2/5, so probability of picking a green ball is 2/5. Okay? I determine the number of green ball in the box. Then I how many blue balls are in the box. So then I want to determine the number of green balls in the box. So first thing, for you to be able to get a number of green balls, per the formula, that's probability of getting green balls times number of sample space. So number of getting green balls will be probability of getting green balls, which is 2/5 times 25. So you can all see that 5 goes here, 1 goes there, 5, 2, 5, 10. So we have 10 green balls. Then the I is saying that, so this is I. How many blue balls are in the box? We know that if I add number of green balls to number of blue balls, to give me the number of the sample space. So in this case, number of green balls is 10 plus number of blue balls should give me 25. So my number of blue balls should be 25 minus 10. Means that number of blue balls is going to be 15. Is that okay?